Welcome to CSEC Chemistry, HSJ Hilton. We are looking at organic chemistry, which is section B 4.1 to 4.4 from the CSEC syllabus, where the general objectives are to understand some of the processes involved in the formation of carbon compounds from natural sources, two, to relate bonding properties of carbon to simple organic compounds, three, to understand the patterns of reactions of the various homologous series of organic compounds, and of course, four, to understand the general pattern involved in the nature and formation of polymers. We start with a look at hydrocarbons. Hydrocarbons are those substances containing carbon and hydrogen only. All right, very important to understand. For hydrocarbons, we'll examine fractional distillation, where we obtain these small hydrocarbon fractions from crude oil, and from the crude oil through the process of cracking, and that's where we will obtain these hydrocarbons. So, very important to understand that hydrocarbons can be saturated or unsaturated. The saturated hydrocarbons are your alkanes, and these undergo substitution reactions and combustion reactions. The hydrocarbons that are unsaturated include your alkenes. These undergo addition as well as combustion reactions, and the addition reactions include hydration, halogenation, and of course, hydrogenation. All right, very important to understand and identify natural gas and petroleum as natural sources of hydrocarbons. So, can we list the main uses of at least three fractions obtained from the fractional distillation of petroleum, including, of course, fuels, petrochemicals, and lubricants? In this look at hydrocarbons, we see that there are natural sources of hydrocarbons. Fossil fuels. These are fuels that have been made by anaerobic decomposition, usually from dead organic matter, which includes plants and animals. Of course, these dead remains have been exposed to high temperature and pressure underground for millions of years. This causes these to transform into what we now know today as fossil fuels, including your coal, peat, natural gas, petroleum, which is your crude oil. Coal and peat, in particularly, are formed from the remains of plants, very important, while, for example, natural gas and petroleum, these are formed from both plants and animals. We'll normally find natural gas and petroleum occurring together. All right, and so these are mined using special drills called rigs. All right, very, very important. Petroleum is the general term for all naturally occurring hydrocarbons. All right, this may include the diesel, fuel oils, gasoline, kerosene. Petroleum is thick, it's flammable, it's a yellow to black mixture of solid, liquid, and gaseous hydrocarbons. Yeah, very, very important. How do we obtain the different fractions, the different gases, petrols, kerosene, etc.? How do we obtain them from crude oil? Well, the process is called fractional distillation. So we have the fractional distillation of petroleum, of crude oil, and from this we get the different fractions coming off at different temperatures. For example, petrol is usually obtained anywhere between 310 and 450 Kelvin. Kerosene anywhere from 430 to 523 Kelvin. Fuel oil and wax usually above 620 degrees Celsius. Now, crude oil is separated into its fractions by following a system that includes: one, the crude oil is first heated in a furnace, the heat will remove the sulfur, and this aims to reduce pollution. Then now a mixture of the liquid and vapor passes into a fractionating column or tower um, that is usually cooler at the top. Yeah, so the vapor passes up the fractionating column through a series of trays containing, of course, bubble caps until it arrives at a tray that is sufficiently cool um, where it can now condense into a liquid. The condensed liquid on each tray is then collected. Yeah, so the hydrocarbons with the shorter chains, they tend to condense in the trays near to the top of the tower. Why? Because it is cooler and they have a lower boiling point because they would have been coming off first than the longer chain hydrocarbons. Bitumen, bitumen, which is a thick layer, is collected at the base of the tower. When you talk about road surfacing, so the tar, that's the bitumen which we use on the roads. All right, so from the fractional distillation of petroleum, we obtain the different fractions. So it's important to know the different fractions, the number of carbons in each chain, the approximate boiling range, the percentage present, and of course the uses for each fraction. All right, very, very important. Next up is our look at the cracking of petroleum fractions. All right, so because we can break up the fractions obtained from crude oil distillation into smaller ones. So from fractional distillation, we obtain fractions from the crude oil. We can now use a process called cracking to break these even into smaller chain hydrocarbons. Why the smaller hydrocarbons are more useful in today's world. Yeah, so the small hydrocarbons such as your ethane, these are usually precursors for many organic compounds. All right, for example, ethanol. Ethane is a precursor for the manufacturing of ethanol. Also in the production of polymers, a lot of polymers, we find a lot of these small chain hydrocarbons being used. So cracking always results in the formation of at least one alkene. Yeah, and is the process for breaking down hydrocarbons into smaller hydrocarbon fractions. This is what is cracking. Yeah, so so we crack the hydrocarbons using only heat, thermal cracking, or we can use a combination of heat and a catalyst, which is catalytic cracking. All right, very important. So thermal cracking, which is also called steam cracking, yeah, uses heat to break up the large hydrocarbons into smaller ones. Thermal cracking is used to manufacture ethylene. Ethylene. All right, very, very important. All right, so thermal cracking is used to manufacture ethylene. During the thermal cracking, the alkenes are usually heated up to between 700K and 1200K, and they're usually under high pressure, usually about 7,000 kilopascals. Yeah, so at this temperature and pressure, the carbon-carbon single bonds break to form radicals. Yeah, the radicals are formed because one electron pair from the pair in a covalent bond gives to each carbon atom. Yeah, catalytic cracking, however, forms ions instead of radicals. The catalytic cracking takes place at lower temperatures than the thermal cracking and lower pressure than thermal cracking as well. Now, catalytic cracking is used mainly to produce motor fuels. So most of the motor fuels where I see out there, it is a result of thermal cracking. Sorry, rather catalytic cracking. Very, very important. Yeah. All right. So let's call it that. Our look at organic chemistry introduction. HSJ Hilton. Peace.